A multi-layer PCB goes through more than 20 manufacturing steps before it's ready to ship. But when it comes to quality, delivery, and long-term reliability, only a few stages carry the highest risks. Today, I will walk you through the 5 key steps that matter most in a multi-layer PCB project. Step 1. Engineering review. Many people think a PCB project starts when the production begins. Actually, it starts much earlier. Before anything goes to a factory floor, we review the design files carefully. Are the stack-up requirements clear? Is the impedance defined correctly? Do the joule files and fabrication notes all match? Because a small issue here can become a much bigger problem later. And once production starts, fixing it usually means delays, rework, and extra cost. That's why engineering review isn't just paperwork. It's where we catch problems before it becomes production problems. Step 2. Inner layers and lamination. In a multi-layer PCB, some of the most critical features are buried inside the board. Once the inner layers are laminated, they are no longer visible. If there is an issue with the inner layer circuitry, restriction, or bonding quality, it is difficult to detect and nearly impossible to correct later in the process. That is why the checks before lamination are so important. We inspect the inner layer patterns, verify layer-to-layer alignment, and control the lamination process carefully to ensure proper bonding and a stable board structure. Because in a multi-layer PCB, long-term reliability often depends on the parts you cannot see. Step 3. Joining and plating. In a multi-layer PCB, reliable connections between layers are essential. This is where joining and plating become critical. It is not simply about drilling holes. Drilling accuracy, hole wall quality, copper deposition, and plating thickness all needs to be carefully controlled. If any parts of the process is not done properly, the board may still look fine on the surface, but issues can appear later during electrical testing, assembly, or even after the product has been in use for some time. That's why we closely inspect and verify the joining and plating process to ensure reliable interlayer connection. Step 4. Outer layers and surface finish. The outer layers are usually the first part of the PCB that people notice, but at this stage, appearance is only part of the picture. The outer layer circle pattern, solder mask, and surface finish all play an important role in the assembly process. We check whether the traces and paths are complete, whether the solder mask restriction and openings are accurate, and whether the surface finish provides good solderability. Getting these details right helps prevent soldering and assembly issues later on. Step 5. Electrical test and final inspection. Before any PCB leaves the factory, it goes through one final stage: electrical testing and final inspection. Electrical testing checks the circuitry for opens and shorts. The final inspection then verifies key specifications, including both dimensions, pore sizes, board thickness, markings, and overall workmanship. Because the goal is not simply to ship a PCB, it is to deliver a board that meets the required specification and performs reliably in the final product. At Fast Turn, we handle both PCB manufacturing and assembly under one roof. For multi-layer PCBs, we pay close attention to the details that matter most: stack-up, impedance control, layer restriction, whole copper quality, surface finish, testing, and final assembly, because every project has its own requirements. Ready to move your PCB or PCBA project forward? Share your project files with our team. We will review your requirements and provide a tailored quotation with the right manufacturing solution.